we are going to see about 8 queens problem and backtracking. This topic comes under data structures and algorithms, and we are going to see this topic related to the course data structures and algorithms, which is meant for first BSc computer science students from 2020-23 syllabus. What is meant by data structure? Data structure is a collection of data and we are going to perform operations over it. And algorithms. Algorithm is a sequence of steps, and these sequence of steps are used to solve problems. And we are going to take 8 queens problem in particular. I am Mrs.E.Ponmalar. I am working as Associate Professor of Computer Science in the Standard Fireworks Rajaratnam College for Women, Sivakasi. So, in the today's session, we are going to introduce the 8 queens problem and about backtracking and the ways to relate 8 queens problem with backtracking, and finally, we will see the steps to solve 4 queens problem with backtracking. In 8 queens problem, what we are going to do is, we are going to arrange the 8 queens on the chessboard pattern in such a way that no queen attack each other. And we are going to mainly concentrate on the backtracking algorithm method. So this backtracking is a general algorithm so that it can be used to solve many computational problems, and the word backtracking means we are going to move through a path, and when you find that there is a solution which cannot be attained, then we backtrack and then continue from that level so that we can reach the solution. So it is actually a problem satisfaction which is used to solve the problem. And the best example for backtracking is the 8 queens puzzle. And here we are going to arrange all the 8 queens in such a way that no queen attack any other queen. And normally what we do is the branch and bound algorithm, divide and conquer algorithm, dynamic programming algorithm, all these algorithms can be used to solve 8 queen problem. And here we are going to particularize it to backtracking. And the 8 queen puzzle, we are going to generalize it as n queen problems, and at present for the example we are going to take n equal to 4 and we will see the steps. And the solution for this 8 queen problem, they have solved up to 23 queens. And the problem was originally mentioned by the player Max Bissell, and over the years they have found the solution for up to 23, and the solution has been given by many inventors like Franz Nank, and then Gunther, and then Glaisher, and then by Dijkstra. We know Dijkstra's algorithm, and he used the depth first backtracking algorithm. Now what is the problem formulation? There are actually states in the chessboard. So if you consider first the empty chessboard, there will be 0 queens on the chessboard. This is the initial state, and then we will be applying the function in such a way that we will add 1 queen 1 by 1 in a square. First we will start with row 1 column 1, and then we will select row 2 column 1. First column we will fill it up, and when you after filling the first column, first row queen, we will go to the second column, and then we will add the second queen and place it in such a way that that queen does not attack the previously placed queen. And if there is a clash, then we will backtrack to the original position and then find out that and place the queen in such a way that it does not attack the previously placed queen. And the goal is all the 8 queens must be on the board such that no queen will attack any other queen. So the backtracking concept is we are going to change the state by placing or adding 1 queen at a time, and each step we will be placing a queen, and if it does not lead to a solution, we will come down to the column, that is we will move on to the previous step, and once the previous step, it identifies that the position of the queen, when you place it, it is going to give a contradiction and attack the queen, then we will go to the still previous step and remove that, and we will move on to the second row in the first column. Similarly, we will go. And this algorithm also introduces a term called as pruning. What is pruning? Pruning means cutting off. So when you include pruning, we will be cutting off a branch of the tree so that the solution will be got at a faster rate. So now the demo for 4 queen problems. First, initially, as we have mentioned, the step 1 is no queen will be on the chessboard. Now first we will place 1 queen in row 1 and column 1. Now there is no attack. Now the second queen, we are going to place it in column 2. Now both the queens attack each other. So we will be moving on to the next row of the second queen, we will place it in the second column, second row. Now also there is an attack. Now we will move on to third row, down the column. And now we find out that the 2 queens doesn't attack. So the third queen, we are going to place it in third column, first row. Now the first queen, Q1, is attacking Q3. So what we are going to do? It is not correct. So you come down. And now the second queen in column 2 is attacking. So that's also not a correct one. So come down in the column. Now again the second queen and the third queen are attacking each other. So what we do? We go to the next row of the third column. Now also there's an attack. The meaning is the second queen you have placed is also not in the correct position. So now you change the queen position of queen 2. Now again the third queen, first row, there is an attack. So second row, we are now finding that there is no attack. So it is correct. Now 3 queens we have placed. Now we will move on to the fourth queen. So we will take the first row for the fourth queen, fourth column. Now there is an attack for 2 queens, Q1 and Q3. So now it is not in the correct position. So come down in the column 4. So the second row, there is an attack. So now come to the third row, there is an attack. So what you do? Come down. Now also there is an attack. So the meaning is both are not in the correct position. So you come away with Q4, now come away with Q3 and come away with Q1. Now Q1 is also not in the correct position. So what you do is bring the queen Q1 to the second row. So what we have assumed as first step, placing the queen 1 in the first column, first row itself was not correct. So now we have backtracked to the position, and now what you do is bring the queen 1 to the second row of the first column. So similarly you are going to repeat for queen 2 and then for queen 3 and then for queen 4, and now the solution is got. So we have one unique solution. Now this method is backtracking. So we have solved the 4 queen problem using backtracking, and exactly same can be applied for 8 queen problem, and generalized means we call it as n queen problem solving with backtracking, and at present they have solved up to 23 queens. And so finally we are going to revisit the steps. So first, step 1, place the first queen in the left upper corner, that is row 1, column 1. Save the attack positions. And these queens, you are going to select the next queen, place it and search for a valid position by placing it in column 2, for example, row 1, row 2, row 3, like that. And if it is not a valid position, then you are going to move to the previous queen, and you repeat these steps in such a way that the 8 or 4 n queens are placed in the correct positions. And then if you find out that all the n queens have been placed in such a way that no queen is attacking each other, then we have found out the solution. So we are going to stop. Now I hope this short session has given you a very clear-cut idea on backtracking and how to use backtracking algorithm for solving n queen problems. I thank one and all for viewing this. Thank you. We will meet till the next course module. Bye.